Good day, good day, good day. Welcome to our YouTube channel. So if you are new here, my name is Tifla. I'm the one who will be helping you with this content, right? So please just help us by subscribing to our YouTube channel. So today we are on trigonometry of grade 12. Last time we did the revision of grade 11 work. So now we are just going to do this content of grade 12 now. So first off, I'll start by proving all the compound angles in grade 12, and I'll show you which ones are supposed to be, or which one are examinable, right? So the first one, obviously you cannot be asked this in the exam, but the other three that comes, you can be asked to prove them using this first one. So I'll start off with this first one, and I'm going to show you how you can prove this and how to prove the other ones using this one. So let's just get straight to it without wasting any much of time. So the main thing about this is trying to prove that cos theta minus beta is the same as cos theta cos beta plus sin theta sin beta, which is your first identity in grade 12, which is called the compound angle, right? So we are going to use two tools that can help us to prove this. So first off, let's use the distance formula in grade 11 when we're doing 2D, 3D trig, right? So we are trying to find the value of AB, the value of AB, right? So in grade 11 we learned that if you're not having a right angle triangle, as you can see, this is not a right angled triangle, right? So we are trying to find the value of this line using what? Using the cosine rule of this. So here you can see that this angle here, it is theta from here up to this line AO, right, or OA, and this line is this angle is beta between the x-axis and the line OB, right? So this will just leave us with this angle here, that is here, the same as theta minus beta, right? Because theta is this bigger angle here and beta is this bigger this small angle here. So the difference between the two give us this angle that is inside here. So how do we find AB? So we know that according to the cosine rule, it says that AB squared, right? AB squared will be the same as AO squared. So this is AO squared plus BO squared. So BO squared minus 2AO BO, and then cos of the angle that is included there. So the angle that is included there, it is theta minus beta. So we're just going to say theta minus beta, right? So we used the 1 unit line. So this line is 1 unit, that line is 1 unit, right? So this will leave us with AB squared being the same as our AO is 1, so this is 1 squared plus, and our BO is also 1 unit, so this will also make this 1 squared, right? Minus 2 1 1, and then cos of theta minus beta, right? So now this makes our AB squared the same as 1 squared plus 1 squared, that just gives us 2, minus 2 multiplied by 1 multiplied by 1, that's just 2, and then 2 multiplied by cos of theta minus beta, just like that, right? So this can be our equation number 1, like that. So the second step, we are going to use the distance formula that we used to use in analytical geometry, right? Between A and B. But you can see that we don't have the coordinates of A and B, but we can make them out, right? So if we can create a right angled triangle there, a right angled triangle there, like that. And here it is beta, this angle between that, right? So we can see that if we are trying to find this side while we are having the hypotenuse there, we can say sine of beta, it is the same as opposite, which is this line. So this is the y line. So it is y over 1, right? So which makes the y just the same as sine of beta. So it means that the y of this point is sine beta, right? And to try to find this x line while we're having this hypotenuse, we can say cos of beta is the same as x over 1. So x over 1, which is the hypotenuse, right? So now it leaves our x value of this point as, so this x value becomes cos of beta, right? So we can write the coordinates of this in terms of cos and theta, right? So starting with x, so it means that our x value, it is cos beta, and our y value will be sine beta, like that, because you know that this is the y value of that. So we can do the same to try to find the coordinates of A, right? So let's just get to it and see. So also we are having a 90 degrees there, right? And the angle between O and this, it is theta, like that. So we can also use the same thing. So to find the y value of this, we can say sine of theta now becomes y over 1, which our y becomes sine of theta. The y of that becomes sine of theta. And we can do the same with x to find the value of x. So cos of theta becomes x over 1, which means that our x, it is just cos of theta. So that are the coordinates there. So let's just write them down. So it means that our coordinates there becomes cos theta, and then the y value becomes sine of theta, like that, right? So now we can use the distance formula between A and B. So the distance formula, we use that AB squared becomes x2 minus x1, right, squared, plus y2 minus y1 squared. That's the distance formula, right? So we can take this as our point number 1, this one as our point number 2, right? So this will leave us with AB squared being the same as the x value there, it is cos theta. So that will be just cos theta minus, here it is cos beta squared, right? And then plus the y value there, it is sine of theta, and the y value there, it is so that will be minus sine of beta squared, right? So we can expand that, or we can multiply that. So that will be AB squared. And if you multiply this, because this is squared, so it means that 2 sets of brackets, right? So this will be cos theta minus cos of beta, cos theta minus cos of beta, right? And then we can write our plus there. That will be sine of theta minus sine of beta, and then sine of theta minus sine of beta, like that, right? So we can multiply out the brackets. So it means that our a b squared now becomes what? This multiplied by that just gives us cos squared theta, right? And this multiplied by that is cos theta cos beta, right? But the negative one. And also if we multiply this and this, it will give us the same, that is negative. So this will be just negative 2 cos theta cos beta, right? And this multiplied by that, that will be a positive cos squared beta, right? And we can do the same procedure on sine. Maybe let me use a different color there. So that will be plus, and this multiplied by that is sine squared theta, and then this and that, it will be negative sine theta sine beta, and also this, so that will give us negative 2 sine theta sine beta, and this and that, that will be just a positive sine squared beta, like that, right? So now let's rearrange this, or let's group this thing up, right? So our AB squared simply becomes cos squared theta plus sine squared theta, right? And then again we can have cos squared theta and that, so that will give us plus cos squared beta plus sine squared beta, right? And now we can have minus 2 cos theta cos beta and minus 2 sine theta sine beta, like that, right? But you know that cos squared theta plus sine squared theta is equals to 1, and also cos squared beta plus sine squared beta is equals to 1. So it means that our AB squared becomes this 1 plus this 1, and then there we can factor out the common factor, which is a negative 2. So that's negative 2, and we can have cos theta cos beta, and then plus sine theta sine beta. So this negative also went with this and gave us that there. So this will leave us with AB squared being the same as this, and this will give us 2, and then minus 2 in bracket cos theta cos beta plus sine theta sine beta, like that, right? So let's see, now we are having equation number 2 there, right? So equation number 1 and equation number 2, right? So let's see how we can combine these equations. So now we are having 2 of these equations. Each is saying AB squared, each is saying AB squared. So this distance is the same. So AB squared is equals to AB squared. So we can equate these equations. So starting with that one, it is saying 2 minus 2 cos theta minus beta. And this equation, it is saying 2 minus 2 cos theta cos beta plus sine theta sine beta, right? So these are the 2 equations that we are having. We equated them, but you can see that there are some things that are the same on the left and on the right hand side. So negative 2 as well. So now this will leave us with cos theta minus beta is the same as cos theta cos beta plus sine theta sine beta. So this is our identity number 1, or compound angle number 1. Most of the times in the exam room, they won't test you on how to prove this one, right? Because you can see that it requires a lot of things, right? It can waste your time, but nevertheless, just know how to prove this. It's just way too cool to know how to prove this. I mean, when you know how to prove something, you will know how to work with it, right? Yes. So this is our compound angle number 1. So the rest of the compound angles that I'm going to do now, they are needed for exam purposes, right? So know how to prove them. So let's get to the second one using this first one, right? So now we are required to prove that cos of theta plus beta is the same as cos theta cos beta minus sin theta sin beta, right? So now we use this same identity to prove this identity, right? So how do we do that? We first make this similar to that, right? With a minus in between. So how can we do that? So we know that this cos theta plus beta, right? It is the same as cos of theta minus beta, like that. So we can see that negative and negative gives us positive. So this is actually equivalent to that. So now what we're going to do, we are going to use this identity with theta the same as theta, and now beta will be negative beta, like that, right? So this will make this equation now becomes cos theta cos negative beta, right, plus sine of theta and then sine of negative beta, like that. So this gives us cos of theta, and cos of a negative angle, it is a positive value, because if it is just negative beta, it means that it is in the fourth quadrant. So this cos is positive, so this will be just cos of beta, right? And then plus, and the sine theta is the same as sine theta, but now sine of negative beta, it is negative theta, so it is negative beta, so this will be negative sine of beta, like that. So lastly, this will mean that our cos of theta multiplied by cos of beta, this negative and this will give us negative sine theta and then sine of beta, which makes this our cos of theta plus beta being the same as that. So this is our second identity now, right? So this is our second compound angle. So the compound angle where there's a negative there with cos, here it will be a positive. Where there's a positive there with cos, there will be negative. So let's go to the third identity and see how you can prove that. So also sometimes you can be required to prove that sine of theta plus beta is equivalent to that using this exact one, right? So what we can do now, we can try to use the co-ratio. So this, our sine of theta plus beta, right? Using the co-ratio, we know that this is equivalent to cos, and then we can introduce the what? The 90, right? So this can be 90 minus theta plus beta, like that. So it is a compound angle. We can do it like that, right? I mean, it is a co-ratio, I mean, so we can reintroduce it like that. So now how can we proceed now? So now we can proceed by multiplying this negative inside, right? So this is equivalent to cos of 90 minus theta minus beta, like that. This negative multiplied everything inside. So now we can take this first angle as our theta. So now this will act as our theta now. Can you see that in this formula? So this can now act as this angle, and this will act as the second angle, right? So still we know that if we're working with cos with a negative there, it will be a positive there, right? So this will be equivalent to cos of, so theta will be this first angle here as 90 minus theta, right? And then cos of theta, and now we can come with a plus this side. Now theta, we introduce that, so that will be sine of 90 minus theta, and now this will be sine of theta, right? But we know the co-ratios. We know that cos 90 minus theta, we talked about this last time, changes to become sine of theta. So this can become now sine of theta, and this will become what? Will become cos theta, nothing will change there, right? And then plus sine 90 minus theta is equivalent to cos of theta, and that doesn't change, as sine of theta. So now we have proved that this is close to that. So this is our third compound angle, or third identity. So now you can see that sine of theta plus beta is equivalent to sine theta cos beta, and then plus cos theta sin beta, like that. So this is our third identity. So now we can move to the fourth one. So it means that if you're having two angles that are adding up like this with sine, it will be sine cos and then plus cosine, like that, right? And now we need to prove that sine of theta minus beta is equivalent to sine theta cos beta minus cos theta sin beta, right? So proving this, we actually use this previous one, right? So let's see. So this, our sine of theta minus beta, right? This is actually the same as sine of, this is exactly the same as sine of theta plus negative beta, like that. So which the positive multiplied by negative brings us back there. So we didn't change anything, it is still the same thing, right? So now we are going to take theta as theta and this negative beta as this second angle, right? So this will be equivalent to, we know that sine theta plus beta is the same as that. So we are going to use that, but now this angle is going to change as the negative one, right? So how do we proceed? So this means that our sine of theta and then our cos of negative beta plus the cos of theta and our sine of negative beta, like that. So now this, as we talked about, this doesn't change, it will remain as cos beta, right? So this will be sine theta cos of beta, because this is in the fourth quadrant, right? So plus cos of theta, and this will be negative sine of beta. So this will be sine theta cos beta, and this negative and this positive gives us negative cos of theta and then sine of beta, like that. So it means that our sine of theta minus beta is equivalent to that. So this is our fourth compound angle that we are going to be using in grade 12, right? So these are the compound angles that we have in grade 12. So cos of theta minus beta is equivalent to that, and cos of theta plus beta is equivalent to that, and sine of theta plus beta is equivalent to that, and also sine theta minus beta is equivalent to that. So these are the compound angles. So on how to use them, do you remember when we were using the identities in grade 11, where you can see tan theta and you quickly change it into sine over cos? So it's more equivalent to that. So on how to use this, I will make the second video explaining how to use them, and we can also have a couple of examples that will help us to use this, right? So we'll just have those 6 type of trig questions again while we are applying these now. So if you have enjoyed, please don't forget to subscribe, don't forget to like, don't forget to share this with your mates, right? I hope you have a great day. Until then, see you on the next one.